Hello everyone! If you're watching this, you should have fallen victim to my aggressive marketing. Well, I don't know what you can do with that, but I do know what I can show you while you're here. This right there is an agility contraption with a monitor and a seat. Let's turn it on. Now, you might have a clue of what's going on, especially if you've seen my earlier works of arts. Yep, you're seeing it right, there's a mouse connected to it, but don't worry, touchscreen is in there too. Going back to the seat, let's see what's inside of the start menu. Conveys game of life, app showcasing inputs, and a Pong. Yep, that was cool. Moving on to inputs app. We can see that this test app does receive all the inputs from the seat, and as for the touch and mouse, this app only receives touch and mouse data when it's actually being used on the app. Furthermore, the windows have been sandboxed this much that all the commands for the app are window relative, not screen relative. This rectangle is being drawn at touch X and touch Y positions. Kinux system automatically passes touch or mouse data to the app, relative to the window. While at it, let's also do this. Almost all contents of the app are being clamped to the size of the window, so only a few rarely used draw functions can break out. Next, let's have a bit of fun with multiple windows. We can see that every app has its own memory, and apps obey the order of focus. I admit, the taskbar might be a little difficult, but blame the 4K Harlim, not me. And of course, both the taskbar and start menu can be scrolled. Regarding those darkened names, more on them later. For now, we have to get something straight, cause while you might think that it's cool, you surely also wonder, can it even be used in the game? Well, let me show you. This ugly piece of awful engineering packs 4 cylinders and a small pump. There is only the Kinux system and not a single other microcontroller. The mouse is a little messed up on this one. I'll correct it after release. Let's just launch the engine control unit up and take it for a ride. As expected of an engine without radiator, it overheats. This completely case-scripted app can handle clutch, can maintain AFR, and protects the engine from blowing up. But you might think, Krolon, that's cool too, but it's awful to have an open window just to have engine running. Worry not, friend, hidden in here is another car, just as ugly as the previous one, with a few changes. It has radiator, for some sanity, 3 cylinders, and is naturally aspirated. In here, if you take a look at the start menu again, all these blackened names are, of course, not apps. These can't be launched. Instead, they're like drivers that are run on every tick in the background, or are global utility functions that can be called by other scripts. And we should have a blackened ECU, so let's get it running and go back into the hangar. Now the icing on the cake, because what's a PC inside of Stoneworks for if it's only a bit cooler Lua? Nah, we gotta do better than that, so we do. Let's take this a little bit bulky pendrive and connect it. Before we do anything, clearly there's only Pong and inputs up, but now when I click that button, Conway's Game of Life has installed on the go. It is however a little bit unoptimized. How does it all work? First, I had to write all of these apps in my language named kscript, outside of Stormworks, of course. Then I used a tool which you can find on GitHub to compile it into machine code that my parser works on. Yes, machine code. It's not string parsing, it's all purely numerical to make the performance at least bearable. Then it's being compressed in a half-bumped LZ77 algorithm and put in there. Why is there two Lua blocks? To have more storage, of course. One is for the system, the other for your apps. They work sequentially and there can be an amount of these and can be expanded with property strings, of course. And inside we can find the compressed data. This block decodes it and sends over to Kinux. In here is screen data and in here is C data. By default user data is there, but you can do with that whatever you want. It goes over to preprocessor, mainly for the UI and screen mouse hybridization, then to Kinux, magic happens, data out, video out.